Hi, this is Nature Going Smart with a special episode in Budapest with Caroline Bellux, our biologist, and she is researching on push-pull technology as the eco-pest management strategy. So today we'll hear a little bit more on that, and I just passed the...
Okay.
Yeah.
So I'm going to start by talking about the problem of the 21st century. Population is increasing and will continue to increase, and therefore agricultural needs to increase its productivity, and it does that by using technology to intensify the production. And the main one used for the moment are pesticides, and these ones are very harmful to the environment and promote insect resistance. So we need to find a way that will intensify production and be eco-friendly. So I've looked at the push-pull technology, which has mainly been researched in Kenya. People in Kenya, the maize fields suffer from damage caused by stem borer moths. These ones lay their eggs at night, and then the eggs hatch, migrate into the stem, which can kill the plants. So the push-pull technology uses 3 different cues to manage the pest. First, you have a push plant. So the maize is an intercrop of a push plant here, and this one emits semiochemicals which repel the moth from the crop. And then the crop is bordered by another plant, which is the pull plant, and this one attracts the moth to it. The pull plant identified in Kenya was Napier grass, and this also offered the benefit that when the eggs hatched in the Napier grass, these ones were inhibited by the sap that it produces. And then there's a third cue, which is attracting the natural enemies of the pest. So basically, when a leaf is damaged by a moth, this one starts emitting semiochemicals, which are a bit of a cry for help. And then they attract natural enemies, which will come and parasitize the eggs or the larvae. So field trials were carried out in Kenya, and they yield positive results. All the crops, which were push-pull crops, had much more of an increased production than the control crops. So my idea was to take this system and apply this idea to more mass production crops, because the push-pull technology is eco-friendly, but it's very labor-intensive, so this would not work on more mass production crops in Europe. So I was thinking that with the help of local farmers, because every local area has different pest problems, and people have knowledge of what plant combining you can do to repel pests. So my idea was to identify push and pull plants, and then identify the semiochemicals which push the pest away, then pull the pest to another crop, and then the semiochemicals which attract the natural enemies. So you would do that by conducting experiments in the laboratory. I'll not go really into detail. Okay. But so once we identify these ones, you could create semiochemical sprays. So semiochemicals are the chemicals which are to which the insects are responding to, that are naturally emitted by the plants. So on the main crop, you would have a main crop on which you would spray the push semiochemicals, and then you would have a border crop on which you would spray the pull semiochemicals. And then the idea would be that all the plants would be genetically modified to always be releasing these toxins which attract natural enemies. So therefore you could increase productivity. This would not be labor intensive, although you would have to carry a lot of research. But I mean, with this you could intensify production while still being eco-friendly. And one of the things that we do not want to do is expand into areas which still contain important biodiversity, because they still the biodiversity in those areas are helping for a lot of the ecosystem services, and as we are already degrading so many things, they're important to our survival. So that's my conclusion, that the push-pull technology could be differentiated to a semi-chemical push-pull strategy, and this would not harm biodiversity, not pollute the underground water. And also because there's 3 different cues, it's not like when you're putting pesticides, there's one cue. So the insect develops resistance to it right away. Whereas there's 3 different cues, so it would be much more confusing, and it would take longer for resistance to develop in insects.
Okay. Thank you very much for your take. And remember, if you want more like technical information on this, you can click on the link below, and you can find all the, let's say, biochemistry that we haven't really gone through at the moment. Thank you very much. Ciao.